I'm not looking for sympathy on this one, but the time is midnight. I started recording at 10 o'clock, did the whole thing, and then my cat jumped on the computer and deleted it before it saved. So I'm now re-recording this video for the second time, and I'm a little bit annoyed at the cat, but I'm going to get through it. Even if it takes me till 2 in the morning, you will have this video on Tuesday ready for Wednesday. So let's hope that we have no hiccups this time. The only thing I will say is a lot of the red writing, a lot of the things I've just left on from the first video, so I'm just going to talk you through them because I just have not got time to rewrite them. My apologies. Okay, it looks like we're recording. So our revision list is on the front. The top section is stuff we revised for paper 1, and it was in our booklet that we did last Friday, and I just want you to go back and have a look at them because they didn't come up in paper 1. Have a little read. Then there's some other things that we didn't look at for paper 1 that we'll look at here. The first section is we did revise for paper 1. It's just solving linear equations. By linear, I mean there's no x squared. It's not quadratic. So it's letters one side, numbers the other, as you can see. Right. Please just everything work this time and no cat interruption. So yeah, so what I've done here, expanded the brackets, taken the minus 20 over to the number side and the plus 5x over to the letter side, leaving me with 3x equals 24. So 24 divided by 3x equals 8. Just in case, right, go for it. Commit to questions. Don't cross things out, okay? Something like this. You might not know what it is to begin with, but you're told, look, the perimeter of this rectangle is 72. Right, this is the perimeter of the rectangle. What is the perimeter of a rectangle? It's adding up everything around the side. 2x, add another 2x, add another x. If I went all the way around, there's 6 x's. There's plus 3 on the top. There'd also be plus 3 on the bottom. Sorry about all the random scribbles there. One's for the first recording of this video, okay? So 6x plus 6 equals what we're told the perimeter is, which is 72. Then we've got an equation. Then we can solve it. Plus 6 goes over as minus 6. Times 6 becomes divide 6. That's linear equations. Upper and lower bounds. Okay, again, I've done them all. I'm just going to talk you through them. We've got an A, B, and C, all correct to 2 significant figures. My arrows are pointing at the second significant figure, the 7, the 9, and the 1. Okay, now, basically, if we're correct in A to the nearest unit, B to the nearest tenth, and C is to the nearest hundredth, but look, let's not overcomplicate it. Generally, an upper and lower bound, generally, unless it's something like the nearest 10 or nearest 5, right? Generally, it involves sticking a 5 on the end. So the upper and lower bound of A are 27.5, 26.5. B, 1.95 and 1.85. And C, 0.815 and 0.805. Where we've got to be super careful, though, is if our sums involve taking away and dividing. And this one involves both. If we're taking away or dividing, to get the least value, we're going to start with the lower bound of the first number and take away as much as we can, right? Same with dividing. These sums will give us the lowest possible answers, okay? Or the reverse of these sums will give us the greatest possible answers. So to find the least value of D, right, A minus B divided by C, I'm going to use the lowest value of A, which I've done here. I'm going to use the biggest value of B to take away from it, which I've used here, and I'm going to use the biggest value of C to divide by, and that will give me the lowest possible answer. What I haven't done is put this in my calculator and worked it out, but be sure to show all your upper and lower bounds like I've done here. A bit neat to this, to say, look, upper bound of A is this, lower bound of A is this, upper bound of B is this, etc. In this one, it's the area of a rectangle. So the area of a rectangle is length times width. But we're told that the area is correct to the nearest centimetre squared. So I've added a 0.5 and taken away a 0.5 from it. Okay, and we're told that the width is correct to the nearest centimetre. So again, I've added a 0.5 and taken away a 0.5. So don't forget to write these upper and lower bounds. To calculate the length, I would divide the area by the width. But to get the greatest length, because this is a division sum, the greatest length is going to come from the upper bound of the area, this number, divided by the lower bound of the width, this area, which is what I'm doing in this sum here, and I'm so sorry this is such a mess. I hope it makes sense to you. Okay, now the answer was this. I wrote quite a lot of digits. Then I realised, hang on, it says give your answer correct to 3 significant figures. So I've counted from the start, 1, 2, 3. So the third significant figure is this 0 here. And because it's followed by a 9, I've rounded it up to 1, answer 13.1. Okay, here we want the greatest possible area of the shaded region, right? All measurements are correct to the nearest centimetre. So what I've done here is like to maximise the shaded region, I want and this is what these arrows are showing here, I want the outside rectangle to be as big as possible, okay? So I've used the upper bounds for the area, 23.5 times 31.5. But to maximise the shaded area, I want the inner rectangle to be as small as possible. So I've used the lower bounds of these, 12.5 and 20.5 multiplied. Once I get these two areas, then I'll just take them away from each other to give me the greatest possible area of the shaded region. Simultaneous equations. I'm not sure this is the best example. You might be better going into your other booklets, right? But because I've only, I don't even know if you can see it, I've only had to multiply the top one by 3 to make the y's the same. That's unusual to only have to change 1, okay? So I've left the second equation alone. I've changed the top one. I've times it all by 3, okay? Then I've looked at the signs. Once the y's are the same, I've got a plus and a minus. They are different signs, so I will add 18 add 6 is 24x, and minus 6 add 14 is 8. Okay, so starting at minus 6 and adding 14, you get 8. X is not 24 divided by 8. X is 8 divided by 24. When I put that into my calculator, I got the answer a third. I was thinking of just leaving it as a third, to be honest, and working with it as a fraction. Probably I should have, because as soon as I change it to a decimal, I kind of lose accuracy, because it's actually 0.3 recurring, right? If I was then substituting it in to here, I've taken the first equation and written it here, but because I know x is a third, right, maybe I should have written instead 6 times a third instead of 0.33333 plus y equals minus 2, right? And if you put that into your calculator, 6 times a third, you'll see it's 2 plus y equals minus 2. And the opposite of this positive 2 is to take it away from here. So y equals minus 4. And they are your answers. 1/3 and minus 4. I would look at other examples of that though, okay? Huge. So important. Pythag and trig, right? Okay. Pythag is when you know 2 sides and you want the third side. Trig is when you know an angle and a side and you want to find another side. Or if you know 2 sides, like in Pythag, but instead of wanting the third side, you actually want to find the angle, like this question here. I know 2 of the sides, but the question is asking me to find this angle x here. Sometimes called, right, don't be put off by this word, in the angle of elevation. Might say find the angle of elevation. All the angle of elevation is the angle from the floor looking up at something. So the floor is where A is, and if I look up at the aeroplane here, that x can be called the angle of elevation. Okay, so labelling wise, I've labelled the hypotenuse. The opposite is opposite that angle, and the adjacent is the third side. I've written SOHCAHTOA, TOA, crossed out SCT, crossed out O because I know it, and A because I know it. I end up using TOA, which I've written as a little triangle here. This is scribble here is me covering the t because I'm trying to find the angle, leaving me the sum O divided by A. So my formula is tan theta, could have used x like they did in the question, tan x, tan theta, whatever, equals O 300 divided by A 400. Okay, but whenever you're finding an angle, the tan, the cos, the sin will need to go over as tan minus 1, cos minus 1, or sin minus 1. So in this case, tan minus 1, and rather than work that out as a number, which you can do, I've left it as a fraction, again for accuracy, and I get 36.9 degrees. On this example, guys, right, my job is to find x, right, but I don't have enough information on the top triangle. I've got more information on the bottom triangle, but look for common lines that belong on both. So if I can work that out, then I have more information for the top triangle, okay? So on the bottom triangle, this is the opposite. It is opposite the angle 48 degrees. This is the hypotenuse, the diagonal, the long side, and then would be the adjacent. In terms of SOHCAHTOA, that is the side I need to know. That is the side I do know. And this side I don't know and I don't care about. So I'm going to be using, and I am jumping ahead here, I'm going to be using TOA. I know A, I want to find O. Okay, so again, TOA. But this time, it's TOA to find it's a side. I'm trying to find the opposite. So the opposite is equal to T, which is tan, and into the brackets we put the angle, close the brackets, times, do make sure you close the bracket there, not put times, right, without closing the bracket, times A, which is 1.2. And my first time go into my calculator here. Let's have a look what we got. We got tan 48, close the brackets, times 1.2 equals, you know, at this point, I know it's not our final answer here, but it's kind of in keeping with the other lengths, which are to 1 decimal place. I'd be quite happy for that to be 1 decimal place, 1.3 centimeters. Something else I've spotted here though, and this can happen in shapes, particularly these triangles, is different units, centimeters, millimeters. So I think that needs to become 2.2 centimeters so that it's the same units as there. So 10 millimeters is a centimeter. Yeah, all right. On the top triangle, it's two sides, but we're not trying to find an angle. It's two sides, and we're trying to find the third side. That's Pythagoras. And because the third side is one of the smaller sides, not the hypotenuse, because we're trying to find a smaller side, it's square this number, square this number, subtract them from each other to find the smaller side, and then square root. Okay, I'm not actually going to do that. I'll leave that to you. So it's square, square, subtract, square root. The other thing they can throw into Pythagorean trig questions is talk of area, right? Area of a triangle. With right angle triangles, the area formula is base times height divided by 2. Okay. Look, in this triangle here, just be careful, which we told the area is 60. BD is the hypotenuse, right? So this and this are the base of and the height, okay? Doesn't matter which way round. So I'll call this the base and this the height, if you want, okay? So to get that area of 60, I'd need to do base times height divided by 2, right? Our job is to work out the length of CD, which I am calling the base, right? If you look at the top triangle, though, we know two sides. Possibly we can use this triangle to work out that third side there, right? Which may then help us going forward to working out CD, the base, okay? So we know two sides, we want the third. This is Pythag as well, but it's square, square. And because we're trying to find the big side, this is an example of adding the squares before square rooting, okay? Again, I'm not going to do it. Hopefully, right, this will make sense in just talking it through, okay? However, what I've written at the side here is base times height divided by 2 equals 60, right? The opposite of dividing by 2 is timesing by 2. In other words, the base times the height will have to make 120 so that when I divide it by 2, I get the area 60, okay? Well, I will now know the height because I've got it from Pythagoras' theorem. I know it now. So whatever that number is, if I do 120 divided by the height, it'll tell me what the base is. So what I am saying is you could very well get area thrown in. Remember to write that if you do. Remember, if you're trying to find B or H, to take that up as a times 2, and then whichever one of those two you know, the base or the height, you can divide your answer by that to work out the other one, okay? Trial and improvement. I'm saying very little, okay? You've got a calculator, use brackets to sub things in. pick the number halfway between what they tell you. If they tell you use trial and improvement is between 2 and 3, start with 2.5. Please write your evaluation. Is this too big, too small? Well, 13.125 is above 0, is too big. So go lower, 2.4, still too big. Go lower, still too big. You get the idea, okay? Once you end up with a number that's too big and the next answer is too small, goes below 0, is minus something, right? Then do a check between those two numbers. I think here, but please, if I'm wrong, I'm so sorry. I think here we find that 2.2 is too big and 2.1 then becomes too small, drops below 0, okay? So we would check 2.15. If 2.15 gives you an answer that's too big, the answer is 2.1. If 2.15, our check, is too small, then our answer is 2.2. Okay, I think. But you work it through yourself, and if I'm wrong, please, please, please correct me. Another bit of, I don't know, bit out of order this one, but another right angle triangles. So it doesn't matter where this comes in the paper, right? It's going to be in the first half somewhere. Oh, right angle triangles. Is it trig? Is it Pythag? Is it SOHCAHTOA? Is it square, square, add, square root, square, square, subtract, square root, okay? It's a bit of a mess now because I've already drawn on it, right? But the idea is on the top triangle, okay, we'll start by trying to find x, and on the top triangle, we know two sides. But we're not trying to find the third side, we're trying to find angle x. So it's not Pythag, it's trig, it's to do with angles, which is trig, okay? I've written SOHCAHTOA, right? I've labelled hypotenuse, opposite, and adjacent, right? It's O and A, I know. It's another example of TOA, right? It's TOA to find the angle. Once I know the angle, we're told that the complete angle here is 90. So whatever x is, I can take it away from 90 to get this bit, which is why I've put a tick there, because I now know this angle. It's 90, take away whatever my answer was. The second part here asks me to work the length AQ, which is this. Now I've labelled this triangle, okay? AQ, the side I want is the hypotenuse. 7.9 centimetres is opposite the angle I now know, and up here would be the adjacent, but again, it's not something I need, so I'm going to be using, I know the angle, I know the opposite, I want to know the hypotenuse, I don't know the adjacent, don't care about it, so I'm using so, right, but I'm using so to find the hypotenuse, so it's O 7.9 divided by sin whatever you worked out that angle to be, okay? All right, we'll do one more, I think, and then we'll take a break and we'll do the rest in the second video, maybe, okay? Right, using a calculator and rounding, basically chucking things in your calculator and then rounding them to decimal places or significant figures or whatever they want, right? So as long as you're pretty nifty with your calculator, you're good to go, right? The only one I'm actually doing here is calculate the reciprocal of. We know reciprocal in this case means 1 over. It means flip, but if it's just a number, you flip it. So I'll put into my calculator 1 over minus 0.07, get the answer on my calculator, and then round it to one decimal place. So minus 14.285 becomes minus 14.3. Okay, that's the only one I'm doing there. Right, I think we'll stop that video there. Even if I need to do 3 shorter videos here, that'll do for now.